Hello everyone, and welcome to our channel Food, Nutrition, and SDGs. In today's video, we will try to learn about one of the important proximate analyses, and that is the determination of moisture content. Moisture content analysis plays a pivotal role in accurately assessing the nutritional composition of food. Accurate moisture content determination therefore plays a key role in ensuring quality for many industries including food, nutraceuticals, and pharmaceuticals. The determination of moisture content in food samples, as part of proximate analysis, follows the principle of removing water through controlled methods and measuring the weight loss to calculate the moisture content. The moisture content of a food can therefore be determined accurately by measuring the number or mass of water molecules present in a known mass of sample. To perform this analysis, we need certain apparatus and equipment. These include 1. China dish. The main purpose of the China dish in this analysis is sample containment, easy handling, even heating, and minimization of contamination. 2. Distilled water. Distilled water is commonly used in laboratory settings for contamination prevention and removal of unwanted materials like dust, dirt, and other impurities. 3. Permanent marker. It is used for labeling of China dishes. 4. Spatula or disposable spoon. They are used to accurately measure, transfer, or handle solid or powdered samples. 5. Electronic digital weighing balance. It is preferred to use this balance as it provides accuracy and precision. They have a digital display along with a tarring function that helps in easy calibration. Moreover, they are versatile in terms of weighing modes. 6. Metal tongs. They are valued for their durability, heat resistance, and ability to securely grip objects. They are essential tools in both domestic and professional environments, offering convenience and safety when handling hot or delicate items. 7. Heat-resistant gloves. Heat-resistant gloves are specialized gloves designed to protect hands and wrists from high temperatures and potential burns. 8. Hot air oven. A hot air oven is a piece of laboratory equipment used for various heating and drying applications. It is indispensable in laboratory settings for various heat treatment processes, ensuring reliability, precision, and sterility in the handling and processing of materials and samples. 9. Desiccators. They are specialized containers used in laboratories to store substances in a low humidity environment, primarily for moisture-sensitive materials. Samples are stored inside desiccators to prevent moisture absorption, degradation, or alteration of their properties. Let's now begin with the experimental procedure of moisture content determination. For this, first of all, wash the China dish thoroughly with tap water followed by applying appropriate detergent or dishwasher available in the laboratory. After the application of the detergent, again wash the China dish with tap water to remove residual unwanted materials like dust, dirt particles, and detergent residues. Finally, wash the China dish at least thrice with distilled water to ensure proper cleaning. Washing a China dish with distilled water 3 times involves using distilled water as the rinsing agent to clean the dish thoroughly. This process helps ensure the removal of any impurities, residues, or contaminants that might affect subsequent usage or testing of the dish. Rinsing 3 times with distilled water guarantees that the dish is free from any potential contaminants that might affect its use in subsequent experiments, tests, or analyses. This meticulous rinsing process helps maintain the integrity of the China dish, especially in laboratory settings where precision and cleanliness are crucial. After thorough washing of the empty China dish, it is initially placed in a hot air oven for 30 to 45 minutes at a temperature of 100 to 110 degrees Celsius to ensure the removal of extra moisture present in the China dish that can cause hindrance in the accuracy of moisture content results of a sample. After placing the empty China dish in a hot air oven, its temperature is adjusted using a digital interface or touch panel that allows users to select and adjust the desired temperature. Once the desired temperature is set, the oven's heating elements or system adjust accordingly to reach and maintain the selected temperature within the oven chamber. After 30 to 45 minutes of drying at a temperature range between 100 to 110 degrees Celsius, the china dish is removed from the hot air oven using metal tongs. This preheated china dish is immediately shifted to the desiccator for at least 30 minutes. Using a desiccator after preheating a china dish for 30 minutes serves the purpose of allowing the dish to cool down to room temperature gradually. This controlled cooling process within the desiccator helps prevent any moisture from recondensing on the surface of the dish. After 30 minutes of cooling in desiccator, the empty china dish is now ready to be weighed. For this, calibrate the electronic weighing balance to 0 by pressing the zeroing button. Then open the glass door by pushing the handle in the forward direction. Then gently place the clean and dry china dish on the balance pan. Carefully close the glass door after placing the empty china dish on the balance pan. Note the reading visible on digital display. This reading will be noted as the weight of an empty china dish. After noting this weight, use the tare button to reset the displayed weight on the balance to 0. After resetting the display weight to 0, open the sliding door to add the food sample to the china dish. For today's determination of moisture content, we have an oat flour sample. We will carefully use a spatula or disposable spoon to transfer the oat flour sample to the china dish. Usually, it is recommended to take sample weights ranging from 5 to 10 grams. After transferring the oat flour sample, note the displayed weight on the weighing balance once the reading is stable. This will serve as the weight of the sample before drying in the final calculations of the determination of moisture content. After noting the weight of the sample before drying, take the sample containing the china dish out of the glass windshield area of the weighing balance and use the tare button to reset the balance to 0. Again, place the china dish containing the oat flour sample on the weighing pan of balance and close the sliding glass door. Note this reading as the weight of the sample plus the china dish before the drying. Let's now begin with the drying procedure. For this, place the sample containing china dish in the hot air oven and close the lid. Set the temperature of the hot air oven in the range of 100 to 110 degrees Celsius using the digital interface or touch display system. After 4 to 5 hours of drying at temperatures ranging from 100 to 110 degrees Celsius, now is the time to take the china dish out of the hot air oven. With the help of metal tongs, carefully grip the china dish and transfer it quickly to the desiccator. Close the door of the hot air oven after taking out the china dish. After 30 to 45 minutes of cooling in a desiccator, it is time to note the final weight of the china dish containing the sample after drying. For this, calibrate the weighing balance to 0 and transfer the china dish to the weighing balance from the desiccator. Close the glass lid and note the final reading on the display of the weighing balance as the weight of the china dish plus the sample after drying. Now, we are all ready to do the necessary calculations required for the determination of moisture content. For this, the following formula is used. Here, W wet means the weight of the sample and china dish before drying, whereas W dry means the weight of the sample and china dish after drying. Similarly, W dish means the weight of the empty china dish. Now let's begin with the calculations using the noted weights in our current experimentation. Here in this experiment, W wet was 60.5659 grams, while W dry was 59.5456 grams. Moreover, the W dish was 52.7062. Now, by putting these values of weights in above stated formula, the equation would be like this. Now all we need to do is to simplify this equation. In the end, we will get the percentage moisture content in our oat sample, and that is 12.98%. Thanks for watching. If you liked today's video, do consider sharing our videos. Moreover, don't forget to like and subscribe to our channel.